We are going to discuss the concept of slope at a given point. And the slope at a given point is the value of a function's derivative at the given point, because a function's derivative is its rate of change. So we're going to give a couple examples of graphs. Right here, this graph of an exponential function has a positive slope for all values of x, because as you can see, if we put a tangent line to the function, the line touching the function at one point is always going to have a positive slope. They aren't drawn very well, I apologize for that, but you get the idea. The function is increasing for all values of x. Now, on the other hand, if we had a function whose derivative is negative for all values of x, an example would be something like this. You can see that if we draw little tangent lines, every tangent line has a negative slope. In this case, the function's decreasing for all values of x, and in general, this illustrates a special concept, which is that if you look at a given point on the graph of a function, you can tell if the derivative at that point is positive or negative or zero by looking at the slope of the tangent line to the function at that given point. An analogy to represent this concept is riding a bike up a hill. Let's say this is the hill and you're riding a bike up the hill. That's supposed to be a bike. If you're going up the hill, the slope is upward. You're going up. If you are at the top of the hill, the slope at that point would be zero because you're not going up or down the hill. And if you were riding down the hill, the slope at that point, whatever point you were on the hill, would be negative because you were going downward. And in general, the process of calculating the slope of a function at a point is a pretty simple concept. All you must do to calculate it is take the derivative of the function, because the derivative is the function's rate of change, and then you take the x-coordinate of the point whose slope you want to know, and you plug the value of x into the derivative. Then you evaluate the expression. And at the end, after you plug the value of x in, you will get a number, a value as your answer, and that value is the slope at the given point. So that is some information on slope at a given point.